Audio Jungle. Audio Jungle.
At this time, we will discuss about static fluid that is very useful for human life. Do you know about fluid? Or have you heard the fluid ever? Let's watch this. Ever you think that why a plane doesn't fall while flying? Or why the ship doesn't sink, even though it's made by iron? Let's see the answer. Fluid is a substance that continually deforms flows, under an applied shear stress, or external force. Fluids are a phase of matter and include liquids, gases and plasmas. The classification of fluid. There are static fluid and dynamic fluid. So, what is the difference of the two? The main characteristic of static fluid that is no move or static. In this case, we will learn about Pascal's law, Archimedes' law, and hydrostatic pressure. And, the next is dynamic fluid. The main characteristic of dynamic fluid, that is has velocity or dynamic. In the dynamic fluid, we will learn about Bernoulli's law and its application in human life, especially in a plane. Archimedes' law states that the upward buoyant force that is exerted on a body immersed in a fluid, whether fully or partially submerged, is equal to the weight of the fluid that the body displaces. Because of Archimedes' law, things can sink, float on the middle, or float in the upper. In the process of sinking, Archimedes' force is smaller than the weight of the object, so the object went to the bottom. Float on the middle occur when the Archimedes' force equal to the weight of the object. And, float on the upper occur when the Archimedes force is equal to the weight of the object too. But on this process, the Archimedes force must to be bigger than the weight of the object. So, the object can move into the upper side of water. The next discussion is about Pascal law. Do you know what Pascal law is? The Pascal's law is a principle in fluid mechanics, given by Blaise Pascal, that states, a pressure change at any point, in a confined and compressible fluid is transmitted throughout the fluid, such that the same change occurs everywhere. Check this illustration. The pressure in A1 surface will be passed through the fluid towards the A2 surface, so that the small force on the small surface is the same as the large force on the large surface, so that even heavy objects can be lifted. For example, a 10-ton car will be lifted with a hydraulic jack. Known the diameter of the pipe at the lever side is 5 centimeters, and the diameter of the pipe at the end of the lifter is 25 centimeters. What is the minimum force that must be applied to the lever so that the car is lifted? This is a solution of the problem.
Audio Jungle.
We just to push at 4,000 Newton to lift a 100,000 Newton car.